Hey, what's up everybody? This tutorial is going to cover how to calculate a p-value for a z-test for p, and then also how to calculate the power of a test. Alright, so this example reads, the city council in a large city has become concerned about the trend toward exclusion of renters with children in apartments within the city. A housing coordinator has decided to select a random sample of 125 apartments and determine for each whether children are permitted. Let P be the true proportion of apartments that prohibit children. If P exceeds 0.75, the City Council will consider appropriate legislation. So A says if 102 of the 125 sampled apartments exclude renters with children, would a level 0.05 test lead you to the conclusion that more than 75% of all apartments exclude children? All right, so in order to answer that question, we do need a p-value. So I'm not going to go through the whole process for a significance test. I'm just going to work through getting the p-value. And then in part B, it says what is the power of the test when p equals 0.8 and alpha is 0.05. All right, so let's notate the information that we're given in the problem. So we know that n is 125. In part A, it tells us that 102 out of the 105 sampled apartments exclude renters with children. So that's going to be used to calculate p hat. So 102 out of 125, which is going to equal 0.816. So that's my sample proportion. I also know that my alpha value, my level of significance, is 0.05. Okay, so what we're going to do is calculate a p-value. So in part A, though, before I do that, I'm going to write my hypotheses. So I'm going to hypothesize for my p parameter. So my p parameter, again, is the true proportion of apartments that prohibit children. So I'm trying to show that p exceeds 0.75. So my null hypothesis is going to be that p is equal to 0.75. And then my alternate is that p is going to exceed or is greater than my 0.75. So those are going to be my null and alternate hypotheses for my significance test. And then what I'm going to do is I'm going to calculate my p-value. To do this, I'm going to use the TI calculator function. So I'm going to go to my TI, I'm going to hit the stat button, tab over to tests. So this is a z-test for p, so I'm going to go and pick the one prop z-test calculator function. That p sub 0, that's my null hypothesis, so that's my 0.75. My next two inputs are x and n. So n is the sample size, 125, and then x is what you divide by the sample size to get your sample proportion. So that's going to be 102. I'm going to pick then the direction of my alternate hypothesis. So this was an upper tailed test or greater than. So I'm going to go and hit that. And then I'm going to go down to calculate. And this, so where it just says p, that's your p value. So 0.004. Okay, so I'm going to write that down for here. So that is my p-value. So that is my p-value. That p-value is less than alpha. So less than 0.05. So that will allow me to reject the null. So if I reject the null, that gives me evidence for the alternate hypothesis. So again, it said, would a level 0.05 test lead you to the conclusion that more than 75% of all apartments exclude children? Then that would be a yes. Since we can reject the null, we have evidence for the alternate. So that's part A. The answer is yes, because our p-value was slightly lower than our level of significance. Okay, so now B says, what is the power of the test when p is equal to 0.8? Also using that alpha value of 0.05. Okay, so what we need to do is first is determine what sample proportion would be the cutoff between rejecting and failing to reject. So what I like to do is I like to set up a picture. I'm going to center that at my null hypothesis of 0.75. Okay, so this is going to be my p hat axis and my z-axis. And I also then need to calculate my standard error. So my standard error is going to be sigma sub p hat. And sigma sub p hat is the square root of my hypothesized p times 1 minus my hypothesized p over my sample size of 125. So if I put that all into my calculator, I get about 0.039 as my standard error. So that's what I'm going to then count by on my picture. So 0.789, 0.827 going to the left. And to the right, to the left, it's going to look like this, -2, -1. Okay, now since I'm doing an upper tail test, I know that I'm going to need to reject the upper 5% of my distribution. So that's going to be about here. So about here. So that is going to be about 0.05. So I'm trying to figure out then what is that number. And in order to figure that out, I can start by finding my z-score. So to find the z-score of that value, I do inverse norm. And I always use the area to the left of that number into inverse norm. So if I'm looking for the upper 5%, I do inverse norm of the lower 95%. And if I put that into my calculator, that outputs a z-score of positive 1.645. Okay, so that's my z-score, and then I need to convert that back to a p hat value. And I do that by taking the mean, adding the z-score times the standard error. Okay, and if I do that, I end up with a sample proportion of 0.814. So what that tells me is I'm going to reject the null when p hat is greater than, for any p hat value greater than 0.814. Okay, so that's kind of the first step of these power problems, is to figure out what is that rejection value. Okay, so now remember what it says is that it says that the actual population proportion is 0.8. Okay, so what I want to do now, so I know basically that my null hypothesis is false. So now I'm trying to evaluate, well, what's the probability of me correctly rejecting that false null hypothesis? So what I'm going to do is I'm going to then make a picture centered at that actual true proportion. So I'm going to center my picture now at 0.8. And I'm still going to count by that same standard error. So 0.839, 0.878, and 0.761, 0.723. Okay, so now what I'm going to do is I'm going to figure out where 0.814 is on my picture, and it's going to be about here. Okay, and what that does then is that separates my picture kind of into two regions. So this region up here is where I reject the null. And this region over here is where I fail to reject the null. Okay, so basically this red region here on the right side is the power. So the power, again, is the probability of rejecting a false null. So that's going to be that region there. So now what I need to do is then go ahead and calculate that value. So now what I'm going to do is I'm going to find a z-score for 0.184. So I'm going to take that minus this new mean, and I'm going to divide by the standard error. And I get a z-score of about 0.361. Okay, so that's my z-score, and that looks about to be where that is on that picture. And then the next thing is I need to actually calculate the power, and the power again is just this red shaded region, so the probability of that. So then what I can do is I can use normal CDF, and my lower boundary is that z-score. My upper boundary, I like to use 1E99 for a large value. If I put that into my calculator, that is 0.359. So that is the power of the test, the probability of correctly rejecting this false null hypothesis. So about a 36% chance of correctly rejecting the false null, again, which is what we call the power. All right, so that is the answer to part B. Hope that makes sense. Thanks for watching.